We are going to start with multiplying and dividing algebraic terms. Multiplication and division of algebraic terms. For example, simplify 7q times 4p times 3pq. Now, in our previous lessons, we have done how to add and subtract algebraic terms, and I told you that in addition and subtraction of algebraic terms, you add the coefficients. But in multiplication, they are different. This time around, we recognize each number to be together, they are alike. The letters are also alike. As we have here, we have Q, we have Q. They are the same. So I'm going to multiply them separately. P is here, P is here, also going to multiply them separately. Is that clear? So, for example, this is 7Q. 7Q is the same thing as 7 times Q. Times 4P is the same thing as 4 times P. And 3PQ is the same thing as 3 times P times Q. Now we're going to multiply the ordinary numbers together. 3 times 4 times 3 as 84. Q times Q. When you are multiplying same alphabet, it's not going to be 2Q. Just like 1 times 1 is 1. But in this case, we're going to use the indices form. Q is raised to power 1. And this Q is also raised to power 1. And the law of indices states that when you are multiplying same number of the same base, you add their powers. So we're only going to add 1 plus 1, which means if there are Q to the power of 2, because there are 2Q here. P times P will give us P to the power of 2. Is that clear? Assuming there are 3, it becomes to the power of 3. If there are 4, it becomes to the power of 4, and so on. I take it again. First, you multiply the number separate, because this is 7Q. 7Q means 7 times Q. That is why you see it as 7 times Q. 4P, 4 times P. 3PQ, 3 times P times Q. Then the numbers, you bring them together. 7, 4, and 3. The letters, you bring them also separate. P to P and Q to Q. Q, Q together, P, P together. So we have 7 times 4 times 3 give us 84. While Q times Q is Q raised to power 2. I told you, if there are 2Q, you write 2 on top. If there are 3, you write 3 on top. Because every number is raised to power 1. Every letter also is raised to power 1. So P times P gave us also P raised to power 2. This is the answer to this question. Okay, let's go to the next example. Now, this is another example. We have 3mn times 2mn times mn. Remember what we did in the first example? We're going to multiply them apart. 3 times m times n, because 3mn means 3 times m times n. So we have 3 times m times n times 2 times m times n. 2 times m times n times m times n times m times n. So 3 times 2, the ordinary numbers to the ordinary number. 3 times 2 is 6, so I'll write 6. Then m times m, I'll just count all the m's. Is that clear? So I have m. How many m do I have? I have 1, 2, 3. So it becomes m to the power of 3. Then let's see how many n we have. N, how many? 1, 2, and 3. N to the power of 3. So this is our answer. Okay, this is another example. We have 4p squared q times 3pq. Remember what we have been doing? We're going to multiply the numbers to the numbers. All the letters, we multiply everything apart first, then we'll now multiply them in terms. The numbers together, the different letters together. So we have 4 p squared, the same thing as p times p. times Q. Then we have times 3 times P times Q. 4 times 3 is 12. P times P times P. There are 3 P's, so it's going to be P raised to the power 3. 1, 2, 3. Then Q, there are 2 Q's, so it's going to be Q raised to the power 2. You see this one, the answer of this, we have P to the power of 3, while this one, the Q is to the power of 2. Is that clear? It depends on the number of letters. It could even be up to the power of 10, 20, 50, 60, and so on. Is that clear? Okay. This is another example. 40 divided by 20a. 40 divided by 20a. Now, this is very simple. I can rewrite this to be as this. This and this are the same, because this line, it means divide. Is that clear? So, now, simple way. If you check very well, 0 can cancel this 0. Is that clear? 2 divided 2 is 1. 2 divided 4 is 2. It means 20 divided 40 will give us 2. So we now have it as not 2a. 2 is left at the numerator. So it remains at the numerator. All over, a is left at the denominator, remains at the denominator. So the answer is 2 over a. Is that clear? Not 2a. Because most of you will say, the one I have 2 here, I have a here, so just 2a. No, 2 divided by a. 2 over a is the answer. Is that clear? Okay, this is another example. We have 6a raised to the power 2b divided by 12a b raised to the power 2. We are going to do the same thing. 6a raised to the power 2b, I can rewrite this to be 6 times a, because a raised to the power 2, a is 2 times, times b, all over 12. 12 is at the denominator because of this division sign, times a times b times b. Now, simple. Okay, now, 6 divided by 12. 6 here, 1. 6 here is 2. A cancel A. Also, B cancel B. Now, you pick out what is left. At the numerator, we are left with 1 times A. 1 times A is the same thing as A. So, we have A all over. At the denominator, we are left with 2. 2 times B is the same thing as 2B. 2B. So this is our answer. Now, this question contains both division and multiplication. You see, 8a raised to the power 2, b raised to the power 2, divided by 7, times 51, or divide by 4ab. So, we make it easier for ourselves by separating this, expanding them. That is 8 times a, because they are a square, times b, divide by 7, times 51, divide by 4, times a times b. Okay, for what can divide? 4 divide 4 is 1, and 4 divide 8 is 2. Also, a can divide a, b can also divide one of these b. So we are left with, at the numerator, 2 times a times b, and also times 51. 2 times 51 will give us 102. Then the alphabet, we have a times b, which is ab. All over, is there anything down? Over 7. Because 7 is here, nothing is here, over 7. So this is our answer. Is that clear?